Welcome back, ladies and gentlemen. In this video, we are going to open up a brand new section 6.3, which is all about parametric equations. The goal in this entire section is to be able to define parametric equations, graph curves parametrically, and solve application problems using parametric equations. In this video, specifically, we are going to be discussing the definition of parametric curves, and I'm going to show you a good, easy reference that will kind of make sense and bring light to the idea of a parametric equation using the unit circle that we are all familiar with. So first and foremost, what is a parametric equation? Okay, well, first and foremost, a parametric equation in its most simplest context is if you think about an ordered pair. We know that an ordered pair on an XY axis, right, is the horizontal shifting left and right and the vertical shifting up and down from the origin. Now, if you think about those ordered pairs, and if you were to assign a function with a new independent variable to each of those ordered pairs, x and y, as you see on the screen, the new independent variable is what we call a parameter. And so to produce the x coordinate, you have some function producing the x coordinate on a parametric curve. You have some function producing the y coordinate on a parametric curve. And so now we are not technically just thinking about the x-axis and the y-axis here. And so instead, we are also kind of bringing into the idea that these x and y coordinates are having a separate function inside of them that is going to produce these ordered pairs. Now, I think personally the easiest way just to think about a parametric equation before just throwing one at you is showing you the example of one that is probably the most familiar to us, and that is the unit circle. So grab your graphing calculators on out, and we're going to take a look at how a unit circle is a parametric equation, and then of course how the entire graph in and of itself is a parametric curve. So first and foremost, click mode and make sure a couple things just for this demonstration. Make sure that you're going to be in degree mode, and then make sure down here you're going to be in parametric mode. Now, I'm not saying that you're always going to necessarily be in degree mode or anything like that. I am using degree mode right now because I think degrees are easier to visualize on the unit circle than radians. So now let's go ahead and take a look here at our y equals. So click y equals, you'll see the x sub 1, y sub 1. Well, what have I told you over and over and over again that the x coordinate of the unit circle represents? That's always going to be your cosine function. Remember, cosine of theta always will produce that x coordinate on our unit circle. And so if that's the case, I'm going to make cosine of my variable. And that's the case in this, it's going to be t. That's going to be our parameter t. But really, we've been thinking of that parameter as theta for a long time now. So similarly for our y, what did we say that y represented? Well, y was the sine function. So the sine of the parameter t, okay, or theta, however you really want to think about it, right, is going to be our y value. Now let's go ahead and take a look here at the window. Now for my window, I have the t min to the t max as 0 to 360. Think about why that makes sense. Well, obviously, if t is kind of representing theta in this example here, our degrees go from 0 to 360. So I'm going to put 0 to 360 in there. And now for my t step, remember that's just kind of as I'm tracing, how is it tracing along the curve? And so I'm just putting 30 in there. You could put 15. It doesn't really matter too much. I'm just going to use 30 because it's going to be one easy example to kind of show what happens at 30 degrees. But that could be a variety of different things. And then don't forget that our range for our cosine and sine function is -1 to 1. I'm going to just put -3 to 3 for my x min and my x max. And then I could put -2 to 2. I could put -3 to 3. I could probably do -1 to 1, but just to kind of make sure that there's enough space. in between. We can visualize the curve. Let's go ahead and graph. And as you can see here, we do produce a circle. This is our unit circle that we've got. Let's go ahead and just hit trace. And so we can see some values here. You can see up top, it says that our x values represent the parametric equation of cosine, and then the parametric equation for sine is our y values. And then if you look down here as we kind of trace along, this makes sense. When we have theta or t being 0, we should expect the cosine to be 1 and the sine to be 0. That makes sense. So now let's go ahead and just trace. I'm going to click my right arrow, and it's going to take me 30 degrees around that circle just because of how I put it in there as 30 degrees. Just because it's an easy visual. Now if you kind of see where we are, think about what happens at 30 degrees. At 30 degrees, all right, we end up having that the cosine value was square root of 3 over 2. Well, that's what this is. Square root of 3 divided by 2 is 0.866. And then the y value, or the sine function, right, sine of theta, was 1/2 at 30 degrees. That's exactly what we have. And I can keep going around and testing that. The next one will bring me at 60 degrees. So at 60 degrees, remember they just switch. So now the cosine is 1/2, and the sine is square root of 3 over 2. And then we can go another 30 degrees, and we're up here at 90. We can go ahead and see that when theta is 90 degrees, or t is 90 degrees in this case, right, we have that the cosine is 0 and the sine is 1. And so I really wanted just to kind of to bring some light into a good example of what a parametric equation is before we start doing some examples using them outside of the unit circle. I think it's probably the easiest way to put it into perspective using this unit circle here. And so as we continue on, we're going to be looking at other graphs, not using the unit circle, using other kind of functions and things of the nature. So just be on the lookout for that, and then we'll be on to our next video.